Hi, my name's Lydia Denton. I'm currently a senior at an early college, getting an associate's in science as well as a certificate in criminal justice. Today I'll be teaching you about trigonomic analysis of blood spatter. High velocity spatter is typically from gunshot wounds, and it's very fine. It's almost like a red mist. Medium velocity spatter is typically from hand-to-hand combat, things that may spread blood, but it's typically thicker droplets. Low velocity spatter is typically from knife wounds or different things that could cut a bigger artery or vein. So when we're trying to find directionality and the point of co-occurrence, we're going to pick a couple really good drops. We're going to circle them and take a ruler and draw where they're coming from. And I'm going to repeat that for every single drop that I've chosen. This is what a more detailed analysis of blood spatter may look like. We can see with this more low velocity blood spatter that it's got multiple points of co-occurrence. There was likely multiple hits or impacts that caused this type of blood spatter. This type of blood spatter shows one point of co-occurrence. Now we're going to find the angle of impact. First we need to choose a couple spots to measure the length and width of. So I'm choosing this point and the length is going to be about 10 millimeters. So our width is going to be about 2 millimeters for this. We always measure in millimeters because it's a more standard and smaller unit of measure. To calculate the angle of impact, we're going to use a mathematical formula, which is arcsine width over length. For our first point, it's going to be inverse sine, 2/10, and make sure you're in degrees and not radians. Our angle of impact for our first point is going to be 11.5 degrees. The angle of impact for our second point is going to be 30 degrees. So I drew a quick diagram which shows where our point of co-occurrence is, our first point and our second point. And this is probably around where our point of origin will be. Now you may be wondering why the angles are different. The reason is because they may have the same point of origin, but they're hitting at different distances. The distance is going to determine the angle. Since they're very different distances, they're going to have two very different angles. In real crime scene recreation, they will do something called stringing. They'll take a string from the blood spatter and string it out at the angle of impact and co-occurrence point to be able to create where that real point of origin in a room may be. There can also be computer models that do the same thing. You may have thought triangles were just for math, but they can be used to catch killers. Trigonomic analysis of blood spatter helps law enforcement and forensic analysts be able to paint a picture of how a crime happened.